Okay, so in this lesson we're going to be solving absolute value equations. So we've been looking at functions and graphing them and looking at all the transformations, but now we're going to actually start looking at absolute value equations and we're going to be solving. So the key concepts here, it says blank force all or part of an equation to return to a positive value. Those are called absolute value expressions. So and then blank are answers that appear to be solutions but are not. They emerge through the process of solving an equation but are not valid solutions. Identify extraneous solutions by verifying potential solutions in the original equation. So these are called extraneous solutions, which means you work it out correctly all the way through, and then at the end when you plug it back in, it doesn't work. All right, so the steps to solve equations in the form, here's our absolute value equation. Absolute value of ax plus b equals c. You're going to isolate the absolute value expression, which means get the bars by itself, and then you're going to ensure that the constant side is greater than or equal to 0. If the constant side is negative, you can't take the absolute value of a number and get a negative answer. You'll separate your two linear equations in two different forms, ax plus b equals c, and then ax plus b equals negative c. So you're going to solve the two related linear equations, and then you're checking for extraneous solutions at the end. So we're going to solve the equation here. So first, what I like to do is I like to circle my absolute value. So I'm taking the absolute value of x. I need to isolate it, which means I need to get it by itself. So I'm first going to subtract 4. And that gives me 2/3 absolute value of x equals 6. And I still have that 2/3 in front that I have to get rid of. We've talked about this before. To get rid of a fraction, we're going to multiply by the reciprocal. So flip it and multiply. So I'm multiplying both sides by 3/2. Those cancel out. I have absolute value of x equals 6 times 3/2 should give you a 9. Okay, so now after we've isolated the absolute value, make sure that this side isn't negative. It's not, it's positive. And then you're separating it into two equations. So I know when I take the absolute value of a number and it equals 9, that number can be 9 or that number can be negative 9. Because if I plug in negative 9 right here, absolute value of that is positive 9. So I have two solutions here. So 9 and negative 9. So you can list it out like this. You can also see it as your solution set. So a curly bracket, list your smallest first and then your largest, and those are your solutions. Now, it tells you to check for extraneous solutions, which means plug it back in and make sure that it's true. So I'm going to check it on this first one and show you what I mean by that, and then you'll have to do it to the other. So I'm plugging in a 9 for x to make sure that it equals 10. So absolute value of 9 is 9. I multiply it by 2/3. So that's going to give me 6 plus 4, which gives me 10. So that one works. Now I'll do the same thing and plug in negative 9. Absolute value of negative 9 is 9 times 2/3 is still 6 plus 4, which gives me 10. So that one also works. So make sure when you solve an absolute value equation that you're checking to make sure that it works. Okay, if it doesn't work, that's an extraneous solution. All right, so let's move on to the next one. So I want to isolate my absolute value. So circle it. I first need to get rid of, let me erase this real quick. I first need to get rid of the 2, so I'm going to add 2 to both sides of the equation. So I have a 5, absolute value of 1/2 a, or x if you want to use x. Those cancel, it equals 20. I'm still not finished. I have to get rid of the 5 by dividing it. So I have absolute value of 1/2 a plus 6 equals 4. Now, once I've isolated it, check, this is positive, so we're good. Now I'm going to set up my two equations. The last one I didn't have to do very much because I just had an x inside the bars. So I have to do 1/2 a plus 6 equals 4. But that inside piece, the inside of the absolute value, can also equal -4, because when I take the absolute value of those two numbers, I still get that positive 4. So I'm going to need to solve both of these. So subtract 6. So that's 1/2 a equals -2. And then to get rid of the fraction, I flip it and multiply. So I'm multiplying both sides by 2. So you end up getting a equals -4. Now, it's not always going to be you solve one and then the other one is just the opposite of that. That's not the case. You have to solve it separately. Subtract 4 or subtract 6. You get 1/2 a equals -10, and flip it and multiply. So you get a equals -20. So I get two separate answers here. So you can either list this out, a equals -4, -20, or your solution set, put the smaller one first, -20 and -4. Make sure that you're also checking it to save some time on the video so it's not so long. I know I've already checked it, so I know if it's correct or not. So plugging those two numbers back in for a on the original, it does work on both. But again, you have to check it, so make sure you're doing that. All right, next one. So circle your absolute value. So you know you want to isolate that. Whatever is not circled, you need to get rid of. So I need to get rid of the -3 by dividing it, because we're multiplying it right now. So those cancel out. We have absolute value of k minus 1 equals -4, because we're dividing that. Okay, so remember, after we've isolated our absolute value, we need to check. Notice this is a -4. There is nothing we can take the absolute value of and get a negative answer. So if you catch that right then, you know there is no solution. So the absolute value, when you take the absolute value, it can never equal a negative. So if this number over here after you've isolated is negative, that's no solution. The symbol for that is a 0 with a slash. So you can write it out or just write no solution. Okay, so let's move on to the next one. So again, if it helps you, circle what is you're taking the absolute value of, so you know you have to isolate that. I first have to subtract 4. So I get -5, absolute value of 3/4 m plus 12 equals 0, and then divide by -5. So absolute value of 3/4 m plus 12. 0 divided by any number is 0. So I've taken the absolute value of, or I've isolated my absolute value. So now looking at that right side, it's not negative. So I'm going to go ahead and set up my two different equations. 3/4 m plus 12 can equal +0. Now, since this is a 0 here, setting up the other one, I'm going to get the same answer because we don't have a positive and a -0. So really, you're just setting up 1. But if you want to show it, you can. So I need to isolate the m, subtract 12. And then flip it and multiply to get rid of the fraction. So you should have m equals, that would be -16. So again, you get one answer on this one because if you have a 0 there, you can't do positive and -0. Okay, so solution set -16, or you can just write this. Okay, again, make sure once you've done that, make sure you're plugging that in to check it on the calculator and make sure that it is true. So again, I'm just skipping over that part just to make my video a little less. Okay, so let's flip on over. Okay, so now we're solving equations with one absolute value with variables on both sides. Okay, so if you have variables on both sides, you still want to isolate your absolute value, But instead, when on the front, we were doing positive and negative of that right side, make sure when you do the negative of that other side that you distribute and change the sign of both of those terms on that right side. And then check for your extraneous solutions at the end. So I'm going to do the same thing that I was doing on the front, and I'm going to circle my absolute value of c minus 3. So I want to divide by 6 at the beginning. And then once we take or isolate the absolute value, we then need to set up our two equations. So c minus 3 can equal 2c, but it can also equal negative 2c. So I'm going to isolate or solve for c. So notice here we have two c's. I'm going to subtract c. It doesn't really matter what side you move your c to. Negative 3 equals c. So there's one solution. And then the other one, I'm going to subtract c. I put add. Subtract c, subtract c. So I get negative 3 equals negative 3c, and then divide by negative 3. So c equals positive 1. So I have my two solutions here. Now remember, once you've solved for it, make sure that you're checking for extraneous solutions. This one actually, because I already know that one of them is not going to work. So I'm going to go ahead and check them and show you what I mean by they don't work. So I'm going to plug in, I'll start out with plugging in the negative 3 for c on my equation. So that's going to be negative 3 minus 3 is a negative 6. Absolute value of that is 6 times 6 is 36. And notice here this gives me negative 36. So those are not equal. So the negative 3 doesn't work. And then plugging in the 1. So 6, 1 minus 3. So 1 minus 3 is a negative 2. Absolute value is 2. Times 6 is 12 equals 12, and that one works. So that's why it's very important that you're checking on both of them. Okay, so the only solution I would have on this one would be a 1. So just one answer here. So make sure that you're checking for extraneous solutions. So you solved it correctly, but when you plug it back in, it doesn't work out. Okay, I'm going to need to erase to have more room. All right, number 2. So isolate your absolute value, so circle it if you need to. Notice there is not anything on the left side of the equation that is not circled, so it's already isolated. So my next step would be to set each. So I'm going to take my 5 minus 3/4 x equal to the right side, 1/4 x plus 2. But remember, it can also, that inside piece can also equal the negative of it. So that's what I was talking about earlier. Make sure you're changing the signs of both of these. So it would be a negative 1/4 x and then a minus 2. Okay, solve them separately. So move your x to one side. I'm going to add 3/4 x to both sides. So with fractions, remember you have to have a common denominator. We do. And when we're adding and subtracting, we only add the numerators. 1 plus 3 is 4. So 4/4 would just give me an x there plus 2. And then I can subtract 2. So that's 3 equals x. Okay, so the other one, solve it separately. So I'm going to go ahead and just add 3/4 x. Again, it doesn't matter which side you move it to. So adding your numerators, negative 1 plus 3 is 2, divided by 4, which is 1/2 x, and then minus 2. So once we have that, we're going to isolate our x, add 2. So you get 7 equals 1/2 x. and then flip it and multiply. So multiply by 2. So you get 14 equals x. All right, so again, plug in a 3, plug in a 14. If you need to use a calculator on that, feel free to do that. Plug it in, make sure the left side equals the right side. I've already plugged them in, so I know both of them work. So 3 and 14 would be your solution set. So again, smallest to largest on that. Okay, gonna have to erase again. We don't have enough room here. All right, so 3. Circle your absolute value so you know what you need to get rid of to isolate. So we want those bars by itself. So we're gonna subtract 6 on both sides. Once we've isolated it, remember you're setting up your two equations. 3n minus 2 can equal n minus 6, which is the right side. Or it can equal the negative of that. 3n minus 2 can equal negative n plus 6. Common mistake, not changing the sign of both. Okay, so now I'm going to solve each one separately. Doesn't matter which side you move your n's to. So I'm going to subtract n. That's 2n minus 2 equals negative 6. We're going to add 2. That's 2n equals negative 4. So our n will be negative 2 after we divide it. Okay, so solving this other one, I'm going to add n. 3n plus n is 4n. Those are 1s in front. Add 2. 4n equals 8, so n will equal 2. Okay, so we will need to check. I'm going to check this one. You're checking all of them. Okay, I'm just plugging in negative 2 for n. So that's going to be negative 6 minus 2 is a negative 8. So absolute value of that is 8. Plus 6 does not give you negative 2, so that one doesn't work. And then plugging in positive 2 for every n that you have. So you get 6 minus 2, which is 4. Absolute value is 4, plus 6 does not give you 2, so that one doesn't work either. So if you solve it correctly, it doesn't work, neither of them work, that means you have no solution. So you can just use the symbol or write it out, no solution. Okay, so moving on to the bottom of this, we're solving equations with two absolute values. So make sure, here's your process, make sure that your absolute expressions are on opposite sides of the equation. You're going to set it up very similar to what we've been doing. We'll have both of them on both sides, but then you'll also have to set it equal to the negative of that right side. You'll solve them separately and then check for extraneous solutions. So notice number 1 here, we're solving the equation. We have absolute values on both sides. So I'm going to set up 2p minus 1 equals 5 minus p. And then I'm also going to set up 2p minus 1 equals negative 5 plus p. You have to do the negative of the other side. So make sure you change the sign of both. So I'm going to solve each one separately. It doesn't matter which side you move your p's to. That's 3p minus 1 equals 5. Add 1. 3p equals 6, so p will equal 2. The next one, again, it doesn't matter which side you move your p's to. I'm going to subtract p. That's a p minus 1 equals negative 5. Add 1, and you get p equals negative 4. So there's our two solutions. Remember, you'll have to plug them in and check them. So just plug in -4 for p on both sides. Plug in +2. Make sure that they equal each other. They both work out. So our solution would be -4 and then 2. So those aren't ordered pairs. Those are your two p values. So -4 is the smallest and then 2. Okay. The next one, notice we have two absolute values, but notice here there's a number in front. Okay, so we'll have to set up 5 minus 3r equals 4, and then we'll have to have parentheses and then the r plus 1. So the reason we have to set parentheses up is because we'll have to distribute and multiply both of those by the 4. So I'm going to solve them separately. This is one equation, so I'm going to add 3r. Subtract 4. So 1 equals 7r. So one of our r's is 1/7. But remember, you have to also set up your other one. So 5 minus 3r equals negative. Now, since we're having to distribute anyways, what you can do is go ahead and just make that 4 negative, and then make sure you distribute the -4. So -4r and then -4. We'll change the signs of both of those. So we'll add 4r. Again, it doesn't matter which side you move your r's to. So that's 5 plus r equals -4. Subtract 5, and you get r equals -9. So again, make sure that you're plugging those in and checking them, making sure the left side equals the right side. Our solution, the smallest is -9, the largest is 1/7. Or you can just write r equals 1/7, r equals -9. So again, just because I'm not checking them on the notes doesn't mean you don't need to check them. I'm just checking them because I already know if they work or not, okay? Just to save some time on the video. All right, I want you to try number 3, so pause the video, work it out, solve each one separately, and then we can talk about it. Okay, so hopefully you paused it and you're working on it on your own. So you would set up 2x plus 6 equals 2 times 5 plus x. So when you distribute, you get 10 plus 2x. And then we need to get x by itself, or get x on one side, so I'm subtracting 2x. So notice here that our x's completely cancel out. And it says 6 equals 10. That is not possible. 6 does not equal 10. So that means we do not have a solution for that one. Okay, so now we need to try the other one. 2x plus 6 equals -2. Remember, don't change the sign inside the parentheses, just the 2 on the outside will do. When you distribute, -10 minus 2x. Okay, so notice on this one, when we add 2x, it does not cancel, so we're good on this one. So we get 4x plus 6 equals -10. And we'll subtract 6. 4x equals -16. So x will be -4. Make sure to plug that one in. There wasn't an x value to even plug in here because they completely canceled. When you plug in -4, it does work, so you can just put a curly bracket for your solution set and then close it. So 4. All right, so this is solving absolute value equations. So make sure if you have any questions, please let me know.